Agents are not compute. Agents live in the data layer. Multi-agent systems are a distributed data problem, and the substrate for that is a sync engine. So agents are basically an LLM in a loop, and what everyone found out is if you take this loop and you run it on a computer, then the LLMs are really good at using the computer. And so you have all these agent harnesses like Claude Code. They work by using the file system and tool calls like bash and grep, etc. And that's been great for software development. In fact, it's completely reinvented software development, but it doesn't take us to the next step. So this is Sunil and Kate from the Cloudflare Agents team, and they're talking about the evolution in waves of agent infrastructure and how the next wave of infra is durable, distributed, online agents. So it's the equivalent of this shift in software from development to factories. But then not just software, it's this factory pattern applied to everything. All knowledge work. It's about bringing agents online and integrating them into operational business processes, team-based collaboration, and governance. So this is the potential of the technology, and this is the shift in the economy right now. But if you look at it from an infrastructure point of view, how do you actually do this today? How do you bring agents online and integrate them into your systems? Well, these are broadly the options. You have a lot of harnesses in sandboxes. You have actor patterns like the durable object, and you have lots of platforms that offer workflow systems. And in a way, these are all ways of modeling the statefulness of the agent. And these are all primitives that were actually available pre-agent. Because when agents came along and you looked around and said, well, how do we model the statefulness of these entities? These were the available primitives from the web service era that could be repurposed to run agents. And they've been very helpful at getting us as far as they have with agents, as we've all been just scrambling to make things work. But they are not going to take us to the next stage of durable, distributed agents. And that is because they're all based on a fundamental misunderstanding of what agents actually are. So if you take sandboxes, they basically take that harness, that LLM in a loop, which was designed for the local computer, and they lift it into a computer in the cloud. And so this makes two key mistakes. Firstly, it enables the fragmentation of resources within the sandbox, where the agent just freely uses the computer and there's no visibility or control over what it's doing inside the sandbox. And I'll return to that later on. Maybe more profoundly, the second one is that it models the agent as a compute node. And that is just obviously wrong, because then if the node dies, the agent dies with it. Agents are not processes. They're not nodes or services or pods. They're not defined by the compute that they run on. Agents are long-lived, logical entities. So they exist even when they're not running. They are actually defined by their conversation history and their memory and state. And so agents live in the data layer. And specifically, agents are logs. The durability, the statefulness lies in the session log. So now if we look at then at the other options, actors and workflows, well, they do model agents on a log of sorts, but they then make the next mistake. Right? They guard access to the log and trap it behind a predefined interface. So for actors, like a durable object, you have a web service interface which sits in between you and the underlying agents. And so if you want to subscribe to it or monitor it, that has to be allowed and exposed by the API. And then for workflows, the log is not actually a session log. It's a kind of memoization tape for replay of the workflow steps. And again, that workflow is predefined. So it's guardrails for the process, but it's also a straitjacket for the agent. And in both cases, the agent can't do things that the interface author or the workflow author didn't anticipate. And that is just a massive failure of imagination. Because agents are not processes. Agents are not workflows. Agents are dynamic, spontaneous, intelligent, creative. So they spawn and communicate through dynamic, distributed topologies. And so when you conceive of agents like this, like a mesh of interconnected data streams, like dynamically evolving clockwork, you can see that the substrate for that is a sync engine. And it's because a sync engine is the technology to tame the complexity of a distributed mesh of data streams, because it handles all of the data wiring and all of the distributed systems complexity that, as an AI engineer, as a product builder, as a platform builder, you don't want to have to deal with. And so this is what we've done at Electric. We've taken our sync tech and we've built the first agent platform on a sync engine. It models agents as long-lived logical entities that live in the data layer, specifically in durable streams. And so every agent gets its own stream, and that's how you communicate with it, and that's also where it fundamentally exists. And then we have a whole layered stack of stream-based data primitives that the agents can use to spawn their own topologies. And the system handles all of the data wiring and communication and coordination for them. Because the logs are on the outside, anyone, other users, agents, systems, teams, can subscribe and connect to the agent sessions at any time. So they are persistent, addressable, subscribable, resumable, forkable. And then because it's also standard web tech under the hood, you can integrate these session logs with anything. And just like our sync tech, the system is designed to work with your stack. So in terms of how you actually define agents, you define them as request handlers that run inside your web app or deployed as serverless functions in something like a Cloudflare worker or a Supabase edge function. And so your agents are your code with your AI engineering running in your app on your compute. And so it's managed agents without the platform lock-in. Now, you may be thinking, hang on, did you say agents in functions? How does that work? Surely agents need isolation. Isn't that the whole point of sandboxes? So you can let the agent make arbitrary tool calls and execute arbitrary code? Well, actually, no. That is the key difference with third wave agent infrastructure. Because when we were just scrambling to make things work, it was okay to have fragmentation in the sandbox, where the harness was executing and spawning anything, and the artifacts and the session logs were literally like hidden files in a .claude folder inside the sandbox. But that's not okay anymore. We need to integrate the agents, both the artifacts and the sessions, into online systems. And so the key enabler for that, the key evolution in the pattern for agents, is to separate the agent logic from the tool call execution. And it's actually by pulling apart the agent logic from the tool call execution that you can properly wire agents into your business systems. Agents in functions that you can scale up and scale down as long-lived logical entities. An agent platform built on a sync engine that you can use to deploy managed agents without the platform lock-in and bring agents online today.